Welcome all and welcome back at C Square. In this lesson we'll talk about area of quadrilaterals and we're gonna start with area of a parallelogram. Remember, a parallelogram is that quadrilateral that has two pairs of opposite sides parallel. In this case, let's say these two sides are parallel, and that is something that you can see on your picture, and these two sides, and you see them, I mark them the same way. Okay, so whenever you have a parallelogram, this is the formula that you can use, which is base times height. The only thing here that you want to be careful about, identify the corresponding height. Most of people really look to this one as a base, then the height is this segment, which is perpendicular on the base. Very similar on this picture, you notice this is the base, this is the height. I want to emphasize here the base is just this segment. The dash part here does not belong to the base. And another case is this one. This is the base and this is the height. So very important to identify the corresponding height and base when you use this formula. And my first example is a pretty easy one. Find the area of this parallelogram, and you notice here you have this 7, this is the height, this is the 15. This 9 you see here, if it's given to you something like that, that is what we call a distractor. And again, the area is base times height. So in this case we're gonna have just 7 times 15, and that will be 105. The area of this parallelogram is 105 square units, since I do not have any units there. This is the second part of the first example, but you notice here also we have a parallelogram. That's what the problem said, we need to find the area. So in this case I'm looking also for area equals base times height, and like I said at the beginning, you really want to see what you need to use. Can you use this one as a base? Not really, because you don't know anything about the height. I mean, probably we can find it, but I think it's better to look to this problem like this. This is the base and this is the height. Okay, now remember, we have a parallelogram. So in a parallelogram, beside the fact that these opposite sides are parallel, they are congruent. I'm going to mark them like this, which means this side is 13. And now this triangle you see here is a right triangle. I'm going to try to draw it here. This is a right triangle. What do we know? This is 5 and this is 13. We need to find this missing leg. I'm going to call it h, like in the picture, because that's the height. And what do we need? What can we use to find that h? We can use Pythagorean theorem. A squared plus b squared equals c squared. In this, we're going to plug this number in, and A is that 5, B is the H. You can switch these two guys, no problem, but C is the hypotenuse, the longest in this right triangle, and this is the hypotenuse, remember, on the other side of the 90 degrees. We're going to solve this equation. 5 squared is 25 plus H squared equals 169. For solving, we need to subtract 25. So we have h squared equals 144, and for finding h we need to take what is called the square root. No need to put plus and minus, because we're talking about geometry. That height needs to be a positive number, and that will be positive 12. A good way to remember, it's this Pythagorean triple, how we called. So if you remember these three numbers, 5, 12 and 13, then you don't have to do this part. So the height is 12. We can go back here and we have the base. The base, be careful, is this 10, it's not 15. It's 10 times the height, which is 12. So the area will be 120 square units. Next part of the lesson, we will look to area of trapezoid, you notice here, this is the formula for the area of trapezoids. So very similar to a parallelogram. You need to be careful how that height is. Do you notice how the height is here and how the height is here? Okay. Other than that, the same. You add the bases. You add the bases, multiply by the height, and divide by 2. It's a way to remember in case it's not given to you. So let's see this example here. We need to find the area of this trapezoid, and one more time, the area of a trapezoid is 1/2. Let me be consistent. It says height first, but you can start with that summation, no problem. B1 plus B2 inside of the parentheses. So do we know all these parts that we need? Yeah, we know the height is 8. We know the two bases 10 and 12. So very simple problem, this one. Just plug it in, and that's it. Height, like I said, is 8, and the two bases 10 and 12. So again, we have a number here that we really don't need, is this distractor. So be careful, sometimes you may have problem like this. So let's take a look here. 1/2 times 8, and again you want to do the parentheses first, that is 22. You can use a calculator if you want, but I think it's a problem that you don't need a calculator. We can simplify like this. So we have left 4 times 22, and then we have 88. The area of this trapezoid is 88 square units. Now let's take a look to this problem. Very similar. We have a trapezoid, however we're going to have to do a little bit more. The same, I'm going to start with the formula. Area equals 1/2 height times height, and then the sum of the two bases, the smallest and the larger base. Okay, now let's take a look. Do we know the height of this guy, which is this? No, really we don't. Do we know the bases? The bases we do know. This is 6, and be careful, the big base is this guy, 7 plus 3, which is 10. So the only thing we need to find before I plug them in this formula is this height, which you notice is in this triangle, which is a right triangle, right? So very similar to the previous problem. I'm going to draw that triangle, and I have 3, 5. The question is how much is the height, and in this case you can use Pythagorean theorem, very similar to what I did before, so you may want to try it. But I would like to put another very nice Pythagorean triple, 3, 4 and 5. So we have 3, this would be 4, and we have the 5, the hypotenuse. This is the only Pythagorean triple that works like this consecutive number, we call them, right? Be careful, there are none others. Okay, so the height is 4 based on this Pythagorean triple. This 4, very important. So now we can go back in the area and say, hey, 1/2 times the height, that 4, times the sum of the two bases, we said 6, and if you remember that 10 we have right here, very important. So very similar, I'm gonna do the parentheses first. 6 plus 10 is 16, and I'm sorry, this is 4 here, and then I'm gonna simplify. In this case works nice, 2 goes in for 2 times, and we have left 2 times 16. The area of this trapezoid is 32 square units. My next part of the lesson will be about the area of 2 other very important quadrilateral, rhombus and kite. You notice this one on the left is a rhombus. Why? All the sides are congruent. We can see that in the picture. The area of the rhombus can be found by multiplying the diagonals, these two diagonals, and divide by 2, or multiply by 1/2. What about the next picture? The next picture here is a kite. You notice these two sides are congruent, these two sides are congruent, however, that's it. The other two are not congruent. But again, a good one for the area to remember. The area is the same. You multiply the diagonals, divide by 2. Okay, the diagonals are these two. So let's see this example. Find the area of each quadrilateral. First of all, the first one is a rhombus. Why this one is a rhombus? This is a rhombus because we notice all the sides are congruent. Okay, so basically now we're looking, this is one of the diagonal, this is the other one. Very simple problem, like I said. It's just 10 times 7 divided by 2. Again, you can simplify here. 2 goes in 10 5 times, and when we have 5 times 7 left, the area will be 35 square units. For part B, very similar, we're looking, but only difference, you notice this one is a kite. So very important to recognize, if that is not given to you, the quadrilateral. This is a kite, because you notice these two sides are congruent, these two sides are congruent, but that's it, nothing else. But the formula is the same. We're gonna multiply the diagonals. So let me write that here. Multiply the diagonals and divide by 2. So we're gonna have here 24 times 16 divided by 2. So we have choices here. I'm gonna say 2 goes in 16 8 times, so you have 24 times 8, and that will be 8 times 4 36, 6 and 3, 8 times 2 16. I'm sorry, 8 times 4, it's 32, not 36. Okay, 32, and 8 times 2 16, 192. Okay, remember this formula works for these two shapes and one more, the square. The square is a special rhombus, so you can use it. It doesn't work for rectangle, for example, or parallelogram, so be careful. Only for kite, rhombus and square, if that is possible. And we have one more problem here. The same thing, we're looking, what is this shape here? First of all, be sure it's one of those. It is a rhombus. Why? Because all the sides are congruent. Now, very important, let's take a look. We have 80 here, which is this segment. It's 7.2. So now TC is going to be also 7.2. Why? Because rhombus, like parallelogram, like rectangle, the diagonal bisect each other. So segment AC, the measure of segment AC will be 2 times 7.2, which is 14.4. This is one of the diagonals. Let me call it D1, because if you remember, the formula says multiply the diagonals and divide by 2. What about the second diagonal? If you take a look for the second diagonal, I think we can do something very similar. Why? Now dt is given, and this is 5.3. TB is going to be also 5.3, because the diagonal of the rhombus bisect each other. So BDE will be nothing else than 2 times 5.3. That will be 10.6. That is the second diagonal. So we just have to plug them in the formula. 14.4 times 10.6 divided by 2. I think I'm going to use a calculator here. And we have 14.4 times 10.6. Let me grab the good calculator. 14.4 times 10.6 0.6, that is 152.64 divided by 2, 76.32. So this is the area of this rhombus. Part B, very similar, the only difference we have a kite. But again, the area of a kite is very similar. If you remember, we have the same formula. So the area will be multiply the diagonals and divide by 2. So let's take a look here. What do we have? We have FV, it's 3.4, which is this segment, right? This segment is going to be also 3.4. So FH will be 2 times 3.4. So remember, under kite is only one diagonal that is bisected, how we call it, this one, the one that cuts the angle that are congruent. The angle EFG and EHG are congruent. So let's take a look to the next part, and the next part will be to find, oh, this one will be 6.8. And what about the second diagonal, EG? Very similar, if you notice. We have FV, I'm sorry, we have EV, it's 2.8. And VG, it's 5.4. So we just have to add these two guys, okay, 2.8 plus 5.4, that will be 2, and then we have 6 plus 2, 8.2, and now we can go back in that formula we start with, and we're gonna have 6.8 times 8.2 divided by 2. So let's see how much that is. 6.8 times 8.2, that will be 54.4 divided by 2, 27.2. So the area of this kite is 27.2 square units. Again, this is a kite, be careful, right? We notice the property of a kite. Sometimes you may need to use what we call trigonometry. If you need help with trigonometry, my YouTube channel has lesson on trigonometry. And let's see how we use it here. Find the area of each quadrilateral. We're going to start with this parallelogram. We know this is a parallelogram. Why? Because you notice these two sides are parallel and these two sides are parallel. So if it's not given to you, look for this type of things to be sure is a parallelogram. If you remember, the area of a parallelogram is base times height. So the question is, what is the base, what is the height? Well, let's take a look. AB here, it's 10. This is this side, it's not a height. Can it be the base? It can. And we have BC, this is 15. Okay, so I think I'm going to use that 15 as a base. And I'm going to find the height that is the corresponding to that base. I think this is the one. It's the easiest way, in my opinion. This is the height, is the segment that is perpendicular from, in this case, vertex A to the base BC. So now if we take a look in this, we have a triangle here. Something like this. We know this is 10. Can we find this height? And I know my triangle is not very accurate. This is 45, this is 45. They have to be the same, right? Because this angle is 90. This is a 45, 45, 90. So you have two choices. You can use trigonometry or you can use the rule for 45, 45, 90, which says n square root of 2. What does it mean for us? It means that in this case n square root of 2 is 10, the hypotenuse is 10. So how do I find n? So let me write this again. This is the equation you want to start with, and I will divide by square root of 2, both sides obviously. So n will be 10 over square root of 2. We can rationalize this by multiplying by square root of 2 over square root of 2. Again, you can see lesson like this on my YouTube channel if you need. And that will give us 10 square root of 2 over 2. So the last thing for n is, to simplify in this case, is 5 square root of 2. So this is how much the height is. Okay, so the height is really 5 square root of 2. We know the base is 15. So we can find the area. That will be 15 times 5 square root of 2. So that will be 75 square root of 2. This is the exact answer, in case you need it. Here we need to round it to the nearest tenth, so I'm gonna do that also. So let's see how much that is. So square root of 2, 1.4 times 75. That's probably the best way to do it. One more time. $75 times 1.4142. I end up with 106. And since I need to round to the nearest tenth, I'm gonna copy the first two decimal. It's 0.6. This is 6, so I'm gonna round it to 106.1. This is the answer we're looking for in this case. Be careful with the rounding. Next example, very similar. We have a trapezoid. If you remember, the area of the trapezoid is 1 over 2 times the height, and we have to add the two bases. So let's take a look to this problem. And we have EF, this is this side, 12, we have FG, this is 16. So we have one of the bases, the small base. The question is, can I find the large base and the height? The answer is yes. Look at here, very similar with the other one. I'm going to draw this segment, which is perpendicular on EH. This is the height. And now again we're looking to this triangle formed, very similar with the other problem. And that is another special right triangle. I'm going to draw it here. This is 12 and this is 60. That is given in the problem very fast. You know, this one is 30. So in this moment, on this 30, 60, 90, what you should remember is the opposite leg to, let's say this one is n, this one will be n square root of 3, the opposite leg to the 60, and the longest one, the hypotenuse, will be 2n. So in other words, in our case, 2n equals 12, because this is the hypotenuse. So if we solve this one, which is very simple, divide by 2, what do we get? We get n equals 6, which is this leg. This is 6 on the other side of 30-degree angles. And this one will be 6 square root of 3. So if you remember this rule, it's a lot easier. Other than that, you can use trigonometric ratio, use a calculator, and you get very similar answer, at least for the second, for the n equals 6. Okay, but that n equals 6 is this piece. Now this is 16. That allows me to find the whole base. This 6 plus 16 is 20. And the n is this height, which is now 6 square root of 3. So we have everything we need. We're going to go back in the formula and we can plug them in. So we have 1 over 2 times the height is 6 square root of 3, and the base is, like I said, 16, the one that was given, and the other one we were able to find it is 22 in fact, right? Because 6 plus 16 is 22. Okay, so let's do some simplification. And probably the first thing, let's to be consistent, I will do the parentheses even though we can do some other simplification. 16 plus 22 is 38. So here I can do this simplification. It could have been done in the previous step. And we have here 3 square root of 3 times 38. So a very good answer in case you do not need to approximate. Just multiply 3 and 38, and that is 114 square root of 3. This is a very, very good answer in case you do not need to approximate. But in our problem, we need to approximate, write your answer to the nearest tenth. So I'm going to do that in the calculator. I'll suggest you first to do square root of 3, which is 1.73 and so on, and multiply by 114. Let me do that. And I end up with this 197.45. Again, I'm going to copy the first two decimals since I need to round it to the nearest tenth. So that means the rounded answer based on the problem is going to be 197.5. On the next example, we need to find the area of this quadrilateral. What is this quadrilateral? Oh, it's a rhombus, because we notice all the sides are congruent. So I'm going to write that here just to be sure. What is the formula? The formula is we multiply the two diagonals and divide by 2. So now let's take a look. Do we have these two diagonals? We don't, but we have this angle is 60, and AB, the side of this rhombus is 10. Oh, but I think we can find pieces. Let's take a look. I'm going to just grab this triangle you see here, ABT. And this is 60. By the way, this angle is 90 because diagonal in a rhombus are perpendicular. That's a property that you want to remember. 30 degrees, and this is 10. So very similar with the other problem, right? This is the 2n, right? So in that form, n square root of 3 and 2n, we know 2n is 10. So n will be 5. 2n is the hypotenuse. So this is 5. That goes with 30 degree on the other side of 30 degree. Remember that. So this will be 5. The next guy will be 5 square root of 3, which goes on the other side of 60 degree. This is the one. And 2n is the one we start. 2n equals 10. So very important, if you remember 30, 60, 90, in this problem will be very easy. Other than that, you have to use trigonometric ratio, sine, cosine, tangent, and you're going to get some approximation of this problem. Okay, so now we know half of the diagonals. What do I mean by that? If you take a look, this is 5 square root of 3, but the other piece is also 5 square root of 3 because the diagonal in a rhombus bisect each other, so they are the same. And this is 5. And this is 5. So now we have what? Area equals. So let's start with these two 5s. 5 plus 5, or 2 times 5 is 10. Times, and then we have 5 square root of 3 plus 5 square root of 3, or 2 times 5 square root of 3, that will be 10 square root of 3. These are how much the diagonals are. So let me write that here. AC, the big diagonal in this guy is going to be 2 times 5 square root of 3, which is 10 square root of 3. And BD, the other diagonal, will be 2 times 5, which will be 10. That's the reason we have those two numbers. So now, in this case, we can get the exact answer. 2 goes in 50 5 times. We have 5 times 10, that is 50 square root of 3. In case you need the exact answer, this is the exact answer. But let's see the approximation for this problem. Let me grab the calculator. So we have 50 times square root of 3. If you remember square root of 3, we can use the calculator. 1.7320 and so on. I end up with 86.60. Again, this is a 0 here, less than 5, so we're gonna stay with 86.6 square units for this rhombus if we round it to the nearest tenth. The next problem, very, very similar. We have a kite in this case, so the same formula. Area of the kite is you multiply the diagonals and divide by 2. But how much are these diagonals? So let's take a look. So this is one diagonal, the one that connects the vertices of the angles that are congruent, and this is the second diagonal. The same property, in fact, with the rhombus. These diagonals are perpendicular. So that's a thing that you remember. And this diagonal EG bisect angle E and angle G. So this will be 45, for example. So which means this is going to be 45. And this is going to be 30, half. Okay, and this one is going to be 60. So those are things that we can just do very fast, remembering some property of kite. So now what can I do to find the diagonals? Okay, we're looking here. FE, this side here is 5 square root of 2. So if you take a look on this triangle, which I'm going to do it here, that is a 45, 45, 90 is the first one we had today. 45, 45, 90, and we know the hypotenuse 5 square root of 2. So you remember again, I'm going to put it here, 45, 45, 90. That means n square root of 2. That's the way I remember. And what is this 5 square root of 2? That is the hypotenuse, is this guy. So let me write it here on the right side, on the left side. We can start with this equation, and we're going to solve for n. So I'm going to divide by square root of 2. Get the n, obviously do the same thing on the other side, and you notice they simplify on the other side also. So we have n equals 5. But what is that 5 for us? This is 5, and this is 5. And in our problem, that means this is 5, and this is 5. And one more thing, this is 5 also, because that diagonal is bisect by EG. So the only thing we need to find out now is this segment, which is given by another special right triangle. The one on the bottom or on top, it's okay, either one is, they are congruent. And this is 60. This is a right angle. This will be 30. And what do we know there? We know this is 5. So the question, how much is this leg? Okay, so remember, n square root of 3 and 2n. That goes with 30, 60, 90. If you remember this, that will be great. Okay, which means this guy, which is on the other side, will be this n square root of 3. Okay, so now we have everything we need. Maybe the only thing I will do, I will find the diagonals. So, for example, FH, the short diagonal, will be 2 times 5. Remember, this is the only one that is bisected, so that will be 10. And EG, on the other hand, you have to add those two parts. You could have added the two parts on the previous diagonal also. And we have 5 plus 5 square root of 3, nothing else we can do here. I will keep it like that, and I'm going to go in the area, and that will be the first diagonal, 10 for example. The second diagonal, I'm going to use a parenthesis since we have an expression involving a radical, this one, and divide by 2. If you want an exact answer, I will suggest you in this case to divide by 2 and use the distributive property, and we have 2 times 5 here, 10. I'm sorry, this is 5 here, not 2. 2 goes in 10 5 times. So we have 5 times 5, which is 25, and 5 times 5 square root of 3, 25 square root of 3. This is the exact answer. Just be careful how you do it on your calculator. Now, I will suggest you, if you have a simple calculator, do first 25 times square root of 3, which I'm going to do it in a moment. 25 times 1.7320508. So I end up with 43. Maybe it's not bad if you write that 25 plus 43.30127. You see, I copy all the decimal I have in my calculator. We are not going to need all of them, but I'll suggest you to do that. So now we're going to add the first 25, and we end up with this value, 68.301. You see, I copy the first 3 digits. Oh, we need to round it to the nearest 10, so we just need to look to this guy. So the answer will be 68.3. My last, almost the last part of the lesson will be finding the area of quadrilateral in a coordinate grid. Okay, so let me cross this N. So you notice already I have here a coordinate grid. I will suggest you always to have something like that. It's very helpful sometimes, most of the time, especially if you can plot the points. So let's start. A, 2 and 3, 2 right, 3 up. B, 7 and 3, 7 right, 3 up. Right here. C, 8 and negative 2, 8 and negative 2, and D, 3 and negative 2. This is the quadrilateral. I'm going to draw it, but some of you may already recognize this guy. This one is a parallelogram. So what is the formula? Area equals base times height. If you need to justify why this is a parallelogram, you can notice these two sides are congruent. These two sides are congruent. Probably that's the easiest way, or parallel. In fact, you can do either way, and that means it's a parallelogram. That will justify this formula here. So how much is the base? We can count 1, 2, 3, 4, 5. So we have here 5 times how much is the height? This is a height 1, 2, 3, 4, 5. It's 5 also. So the area will be 25 square units. So I think it's a very simple problem. If you have graph paper, that's the way I will do it. The second one, a very similar one, and I will do the same thing. I will plot the points. The first point, -1 and -1. Go one left, one down, right here. B, -4 and 3. Go 4 left, 3 up. C, -1 and 7. 1 left, 7 up, right here. And D, 2 and 3, 2 right, 3 up. So what is this shape here? Okay. It looks for me is either a rhombus or a kite. To be honest with you, I really don't care if it's a rhombus or a kite, because either one has the same formula. Multiply the diagonals and divide by 2. Okay, so what are the diagonals here? The diagonals are these two segments, this one, which we can count 1, 2, 3, 4, 5, 6, 7, 8. So I'm gonna have 8 times the second diagonal is this one, and you notice they are perpendicular. You can see that in this rectangular grid. 1, 2, 3, 4, 5, 6, 8 times 6, divide by 2. So that will be 2 goes in 6 3 times, 8 times 4, 20, 8 times 3, I'm sorry, 24 square units. If you need to justify why this, we can use this formula. I think the best way is to take a look to the size of this sides of this quadrilateral. And if you notice, we can use Pythagorean theorem, 1, 2, 3, 4, 4 and 3 here, and we can get this one. This will be 5, by the way. Is the same for the other one? Yes, the same for this one. This will be 5 also. And you know what? This is a rhombus. All sides are 5, in case you need to justify why you use this formula. And by the way, this diagonal was 6. So one more time, I will say it's important to have graph paper sometime. It helps a lot, makes your life easier. Last problem in my lesson today is this one. The area of a rhombus is 42 square inches. Oh, this one is a rhombus. That's important to know. And what do we know about the rhombus? The diagonals are perpendicular. Find the length of DE. So for how much this one is, let me call it X, I guess. If AE, it's 3.5. Okay, so one easy way, I think the easiest way, is to look to this formula. We discuss about area of a rhombus, multiply the diagonals, divide by 2. And let's see, in this formula we know the area. The thing we need to find out is one of the diagonals. So what about this one? So this is 3.5. This is going to be 3.5. Remember that property I mentioned, the diagonal in a rhombus bisect each other. So this is 3.5, this is 3.5. So the big diagonal AC will be 2 times 3.5, which is 7. And let's say that one is the first diagonal. So now I can go in this formula we have here. We know the area is 42 square inches. The first diagonal is, we found it, 7. The second diagonal we need to find out and divide by 2. So how would you solve here for the sub 2? Multiply by 2, I will say that's the easiest way. Don't forget to do the same thing on the other side. So we have 84 here equal 7 times D2 and divide by 7. The second diagonal in this case will be 12. The second diagonal being this segment, right? DB. And you notice I call this X, this one will be X. So you can write a short equation in case you need it. Sometimes you don't. 2x equals what? 12, the second diagonal. So x will be 6. So the length of DE is 6 units. If you enjoyed this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.